So first numerical we are discussing here. Then the average refractive index of the core, and cladding is 1.5 and 1.48, 1.5 and 1.48. Okay, respectively in an optical fiber. Find the numerical aperture and the angle of acceptance. Okay. So students, no need to solve the question here. Just understand the question. What is given? What is that? The numerical aperture is there. What is given here? Numerical. Sorry. Optical fiber is there. What is the optical fiber content? One is core. Another one is the clad is there. Okay. This is the axis. This is the core. This is the cladding. The refractive index of the core is given 1.5. Refractive index of the clad is given 1.48. Okay, we know that the fundamental one, refractive index of core is always greater than n2. That all. Write the solution and all. Given that n1 is equal to this, n2 is equal to this, then apply the formula for the numerical aperture. We know that, okay, numerical aperture is equal to n1 square minus n2 square under root divided by n0. Okay, n0 is the surrounding where it is keeping. We assume that n0 is not given, means it is in air. Here the refractive index of air is equal to 1. Apply the formula for that. Na is equal to how much? Na is equal to, so n1 is 1.50 square minus 1.48 square, okay, divided by 1. So if you calculate this, means you will get near about 244. Okay, so therefore this is called the numerical aperture. The angle of acceptance means Na is also called as a sin theta naught. This is equal to 0.244. The theta naught we want, therefore you will take this here, sin inverse of 0.244. If you take sin inverse, means it will be near about 14 degree, 14.1 degree you will take. This is the angle of acceptance. This is a numerical aperture. So this comes second numerical. Okay, so the fractional index change of an optical fiber. Okay, the refractive index of the core, is given. Refractive index of the core is 1 point, index of the core is 0.00515, and the refractive index of the cladding 1.53 respectively. The cladding refractive index is, okay, somewhat it is wrong. The fractional index change of optical fiber. Yes. Okay, the fractional index of optical fiber. What is the fractional index before? So this is the core, this is the cladding. So the difference of core to cladding to the core, that is n1 minus n2 divided by n1. This is called fractional index change. We know the fractional index change is given. What is the fractional index change? What is given? 0.00515. Refractive index of this core is given 1.53. So this is given. What we are going to determine here? The calculate the refractive index of the cladding here. Okay. So formula is what? Del, we know that. Okay, refractive change is n1 minus n2 divided by n1. So I want n2. Therefore, what we will write here? Okay. Take out delta n1 is equal to n1 minus of n2, or n2 is equal to, or we will take n1 here, means n2 is equal to n1 minus of del of n1. Substitute the values, you will get this. Okay, what is the value? N1 is equal to 1.533 something is there, and del is there 0.00. What is the value? 515 into n1 value you will write, substitute. So we will get, okay, sorry, this is minus, you will get the value, that is 1.525. This is the cladding. So in this way you have to calculate. How many minutes for?
420.
Another third problem. Okay. An optical fiber has a material of refractive index. Optical fiber has a material of refractive index material of core. Okay, its material refractive index of its 1.55, and its cladding material has the refractive index 1.55 and 1.50. These are the two materials. It means n1 is equal to 1.55 and not n2 is equal to 1.50. Core and cladding is there. Okay, the refractive index, the light is bounces or launched into an air. Calculate its numerical aperture of the optical fiber. Very good. okay, it is kept in the air, then you can determine the numerical aperture. We know that again, numerical aperture is equal to n1 square minus n2 square divided by n square. This is under root. Substitute the values, all substitute the values. 1.55 square minus 1.50 square, okay, under root divided by 1. 1 is the refractive index of material, okay, of the surroundings. Therefore you will get that value, so 0.39. okay, angle of acceptance means, you know that sin theta naught is equal to numerical aperture. Therefore this will be sin theta naught is equal to 0.39. Therefore theta naught is equal to sin inverse of, okay, 0.39. so this may be, it is near about 23 degree. So this is fraction index change means substitute the values of all n1 minus n2 divided by n1, okay, n1 is no 1.55 minus n2 is 1.50 divided by 1.55, then you will get that value 0.032. so this is the fraction index.